So welcome back to Percent Composition. I know you're having a great time. I am, can't you tell? Ha ha ha. All right, so percent composition, we left off with calculations like this, right? So I went ahead and did the preliminary steps, and we're doing the percent composition for calcium carbonate, CaCO3. So I've listed calcium, carbon, and oxygen. And then I went through and brought in their weights, 40.08, 12.01, 16. And then I brought in the multipliers, which were the subscripts for each one. Then I got the totals and I added them all up to calculate formula weight. So typically, the percent composition calculation would now kick in. And that's where I'm going to kind of pick up now, right? So just to save time, I did all of this preliminary work for you. So to calculate percent composition, I would take 40.08 divided by 100.09, 12.01 divided by 100.09, and then 48 divided by 100.09. Now, when I do this, I'm going to get answers that are really close to the weights, and the reason is because this formula weight is 100.09%. So it's kind of silly in a way, but we still go through the process. So 40.08, then we're going to divide that by 100.09, just like we did before in the previous video. And then we multiply by a 100 to change it into a percentage. And I get 40.04%. So notice that the number changed a little bit, but not by much. And again, it's because I'm dividing by basically 100 in a way. All right, so next, 12.01. And then I'm going to divide that by 100.09. Times it by 100 to change it to a percentage. And I get basically 12%. 12.00%. All right, so finally with my last one, I've got 48. Divide that by 100.09. And then times it by 100 to get it to a percentage. And that gives me 47.96%. So I've calculated the percent composition for each one of these. And that could be one of your questions. Calculate the percent composition of calcium carbonate, and that's what you would give me. 40% calcium, 12% carbon, 48% oxygen, depending on how you want it around your numbers. There you go. But here's where it turns on its head a little bit, and this is where practicality really kicks in. Because let's say that we have calcium carbonate into a pill, right? And that pill someone eats because their stomach feels upset, and maybe they have a heartburn. Maybe they have acid indigestion. So they eat a calcium carbonate pill. Yum, yum, yum. Tums and Rolaids. It dissolves up in their stomach. And let's say that that pill is a 500 milligram pill by weight. The question would be, how many milligrams of carbonate is present? Or how many milligrams of calcium are present? That's really where percent composition comes into play. But before you can answer that type of question, you have to know the basics of percent composition first. Meaning, up there at the very top, we've already done that calculation. That was percent composition right up there. So once we do that, this is going to be a pretty simple fix for us. We've got a 500 milligram pill. We want to know how much carbonate is present in that pill and how much calcium is present in that pill. How do we do it? Well, I take the pill weight, 500 milligrams, and I multiply by the percentage. We said calcium carbonate right up here at the top. If it's just calcium carbonate in the pill and that's it, that's all that there's present. If all of that's calcium carbonate, we said that calcium is 40.04% of that number. Okay, so if there's a 500 milligram pill, 40.04% of that weight is coming from calcium. So I'll take 500 and I multiply it by 40.04%. Well, if you got a cheap, skanky calculator, it's got a percent key on there. You take 500 times 40.04% and you hit enter, and it gives you the answer. If you spent close to $200 on a calculator, it doesn't have a percent key. So we're going to have to change this to a decimal. So we divide by a 100. So change that to a decimal. That way you can multiply these two values together, and you'll end up getting the weight of calcium in that particular 500 milligram pill. So 500 times 0.4004, enter, gives me 200.2. So 200.2 milligrams, because it was milligram in the question, 200 milligrams is coming from calcium out of the 500. That's the power of percent composition. That's the types of problems that we use percent composition in most often. Okay? Well, let's look at calcium carbonate, or the carbonate piece. The problem here is that we broke it up individually, right? Calcium had its own line, carbon and oxygen had its own line. But look, carbon and oxygen, well, that's the only area that it came from in the compound, right? So that means if I take carbon weight and oxygen weight and I added them all together, that's really the only source of calcium carbonate that's present. I don't see a carbon anywhere else in the molecule. I don't see an oxygen listed anywhere else in the molecule. They go together, right? Well, instead of doing some extra work, let's just take a look at the percentages. Here's calcium, there's carbon, there's oxygen. So if I'm focused on carbonate, CO3, and that's the only area where carbon and oxygen is located, then why not just add these two things together? Because that's my carbon and that's my oxygen. Now, if you're uncomfortable with that, you can do another formula weight percent composition calculation. You would just do like we did in the last video and keep water together. You would keep carbonate together here. So carbonate, 16, 16, 16, and then carbon is 12. You add all of that together, then you multiply by 1, because there's just one carbonate for every molecule. Or, if you're okay with the idea, this is the only place carbon's at, it's the only place oxygen's at, so you might as well keep it together. Just add these two things together. You already did it. Why do you want to do it again? So 12% plus 47.96% gives me 59.96. So 59.96% times 500 milligram tablet. Well, convert that over to a decimal, 0.5996. Multiply that by 500. So there's my decimal. Multiply by 500. And I'm going to get 299.8. So 299.8 milligrams. Meaning that that 500 milligram tablet, close to 300 milligrams of that weight, is going to come from carbonate. The other 200 milligrams of weight is going to come from calcium. Now, these are very common calculations. I've got these pills, I've got this substance that was submitted to the lab. I need to figure out how much calcium is present, how much carbonate is present. And I can do that in terms of a pill, but I can also do it in terms of solution prep. So what do I mean by that? Well, when you get to the part per million and part per billion videos, you're going to see. So let's say that I have calcium carbonate, and I dissolve this stuff in a solvent. There's a couple of ways to look at it. In my volumetric flask, I've got some solid calcium carbonate here, and then I add my solvent to go up to the line. Make sure it's dissolved, make sure that it's to the line, prim and proper. And I can talk about a concentration based on the calcium carbonate. How much calcium carbonate is present. So let's say that I weighed out 250 milligrams of calcium carbonate and I dissolved it. Well, I can perform a concentration calculation and I can report this number in different units. Depending on what's required, I can report it in probably 6 or 7 different ways, at least. All right, but let's say that we're not really focused on calcium carbonate, not as the whole. Let's say that we used calcium carbonate because we needed calcium. Or we used calcium carbonate because we needed carbonate. Well, I can report concentrations in terms of just that piece. So the first way that we can look at this is if I dissolve that salt into a solvent and dilute it to the line, I can give you a concentration of the salt as a whole. Not a problem. But if I take 250 milligrams of calcium carbonate and dissolve it, I can also report the concentration in terms of just calcium. That's it. I don't care about the carbonate piece. That's not what I'm after. I'm just after the calcium part, maybe. Or if I take the 250 milligrams of calcium carbonate, I could also report the concentration of just the carbonate piece. We don't care about the calcium in this case. So it really depends on the point of reference that you want to take away. All of these are okay. All 3 scenarios will work here depending on what we want to do in a laboratory with our solution or the standard that we've made. So in order to calculate the concentrations, we need to have an idea of percent compositions, right? Meaning that we just calculated the percent composition of calcium carbonate. And that percentage was used to give us a better idea of the amounts of each piece. Same thing can happen here. So if I wanted to report concentration in terms of calcium carbonate, keep the entire weight. Use that value to calculate the concentration. If you wanted to calculate the concentration of just calcium, then this means find the percent of calcium with the percent composition calculation. Multiply that percentage by your starting amount. That will tell you the actual number of milligrams of calcium that you are using, so that way you can calculate a concentration based off of that number. And then finally with the carbonate, do the same thing, right? With the carbonate, find the percentage of CaC or CO3. Once you do that, multiply by the milligram that you have used in the lab, 250, that came from the total thing, and that will give you the milligrams of carbonate that you are using in that flask. And all 3 are proper to report. Concentration based on the salt, concentration based on maybe the calcium only, concentration based on the carbonate only, and that's kind of where I'm going to leave this for now. You'll see where this is going to lead in the part per billion and part per million videos, and the reason I'm going to leave it here is because we've not really talked about concentration yet. We've not talked about how to take these amounts, these milligram amounts, and convert that over into a proper concentration unit like molarity or normality or part per million or part per billion. So there's going to be some more background information associated with this, but I wanted to give you a heads up on where this is going to land. All right? So if I want to do a quick example, and let's say that I have a 750 milligram tablet, and that tablet is MgCl2, right? How much magnesium is present. So I'm going to quickly do this for you. I'm going to calculate the formula weight for magnesium chloride. Magnesium's 24.31. The chlorine is 35.45. And I have another chlorine, so another 35.45. So that formula weight is 95.21. Well, the magnesium was 24.31 of that. So I'm going to calculate the percentage of magnesium. So magnesium, 24.31 divided by 95.21 multiplied by a 100, that gives me 25.53%. So my magnesium is 25.53% magnesium. That means out of this weight that I have used, 25% of that total is going to be weight that's from magnesium. So 750 times 0.2553 equals 191.48. So 191.48 milligrams is coming from magnesium. I can then use that number to calculate concentration of magnesium a little bit later on. When you get through those videos, we'll end up talking about them. But again, this is just to preempt you for those types of discussions that will happen in the future. So that's percent composition, and that's another way to look at it. Basically, looking at an amount of stuff that you have in your hands and figuring out, well, how much magnesium is actually there, or how much chlorine is actually there. And I can do these calculations a number of different ways. So I think if you watch these past two videos, you're pretty comfortable with the idea of percent composition and how to calculate it. And you might be pretty comfortable with the majority of the problems in the assignment too. So do a quick review of your notes. Make sure that you're not really fumbling on anything. If you do, give me a question, give me an email, and I'll be glad to answer it. And then go ahead and tackle the assignment problems and see how well you do on them. So good luck on the assignment. Come back. We'll talk about the next category of concentration, and we'll keep chugging through all of these calculations here in the beginning of the course.